Okay, so for my project, doing the mole concept, so first is why do we use moles? The definition of a mole is the quantity of anything that has the same number of particles found in 12.000 grams of carbon-12. That number of particles is Avogadro's number, which is roughly 6.02 times 10 to the 23rd. A mole of carbon atoms is 6.02 times 10 to the 23rd carbon atoms. A mole is practically just a unit for a number that is used instead of writing a long number. So you can think of a mole like you would think of a dozen, and so it's just like a quantity that represents the number. So a dozen is 12 of something, and then a mole is 6.02 times 10 to the 23rd of something. So you would write mole you can write that instead of the 6.02 times 10 to the 23rd, just like you would write a dozen instead of like 12 for like eggs or something that you're using for a dozen. Converting mass to moles. You can use the molar mass of the substance to convert between mass and number of moles. Then you can use Avogadro's number to convert the number of moles into the number of atoms. So 1 mole equals 6.02 times 10 to the 23rd. So you can do, I have it on the paper that you'll have. And then moles to particles. You will use Avogadro's number, which is 6.02 times 10 to the 23rd, like I said. You will set up a cross multiplication chart that is shown on the paper. You may put your given multiplied by Avogadro's number over 1 mole of your element. So I have 22 grams Cu, and then next to it, so you have times 1 mole Cu over 63.5 grams of Cu, and then your grams of Cu can cancel out, which will equal 0.35 moles of Cu, which is this chart right here if you're looking at it. And then moles of one substance, 2 moles of another substance in the balanced equation. So to convert from one mass, which will be your substance A, to another mass, which will be your substance B, you must convert the mass A first to moles, so you can have them all in the same category. Then use the mole-to-mole conversion factor, which would be B divided by A. Then convert the mole amount of B back to grams of B. So you have to get them both to be moles so they can multiply naturally. So my example problem is ammonia, which is NH3, is produced by the reaction of nitrogen, which is N2, and hydrogen H2 gases. How much ammonia will be produced if 22.0 grams of H2 reacts with excess N2? So you're going to follow the steps to solve, which will be N2 plus 3H equals 2NH3. So then you take that 22.0 grams of H2 and you'll multiply it by 1 mole of N2 over 2.02 grams of H2. Your H2s can cancel and you're going to be left with 10.9 moles of N2. Moving on, then you take your 10.09 moles of N2 times 3 grams of H2 over 1 mole N2 equals 32.7 H2. It's kind of confusing when you say it all, but you can look at this paper right here and it runs it all through there. So yeah, that's what you do in the mole concept using moles. It's pretty simple once you get it down. You just have to remember your Avogadro's number, and you can pretty much put it all into your calculator once you set it up on the cross multiplication. So yeah, that's it. Thank you.